Okay, so now we're going to look at the first part of algorithm design and problem solving, which is program development lifecycle. So the first part is analysis. Now we can break down analysis into two parts, abstraction and decomposition. What is abstraction? Abstraction is basically removing unnecessary details to focus on the essential features. And decomposition is breaking down a problem into smaller, more manageable subproblems. So let's say we have a chocolate bar, just divide it into like 8 pieces, and we need to distribute it between 4 friends. Okay? Friend 1, friend 2, friend 3, and friend 4. Okay? So, how do we apply abstraction to this? First, what we're going to do is we're going to remove the unnecessary details like what color of clothes the friends are wearing, what is the company of the chocolate, and how is the weather. These are all unnecessary because you do not need them. So, we remove them. And then decomposition is breaking down the problem into smaller, more manageable tasks. Okay? So it's like you see the number of chocolate pieces you can have. So in this case, you have 8 pieces. And then the number of friends, 4. And basically break it down into smaller and smaller pieces, smaller and smaller sections, basically. Okay. So that's basically analysis. Then we have design stage. In design stage, designing is basically the process of planning a solution to a problem. Designing involves identifying how the solution will work, including algorithms, inputs, outputs, and processes before the coding begins. So it's just like designing. Um, you make something, you plan out how it's going to be. That's basically it. But there are 3 ways you can design things for your algorithm. And the 3 things are structured diagram, flowcharts, and pseudocode. So a structured diagram, as you guys can see over here, a diagram that shows the breakdown of a problem into smaller sub-problems. Okay, so you can see the portion of a calculator over here. How is the calculator made? So the calculator first has an input to be made, then a process, then an output. So for the input you need a number, and then you need a symbol, and then you need the second number. Let's say 1 plus 1. You have your number, your symbol, and your number again. And then what happens in the process? Number 1, symbol number 2. Okay? So it's basically like 1 plus 1. You carry out this process. And then the output is outputting the answer. So yeah, this is basically how a structured diagram is represented. Next is flowcharts. Flowcharts, now there are 4 main, very important flowchart shapes. And you need to memorize them so that you can use them in exam questions you might have. So for starting or stopping an algorithm, it is this oval shaped shape, which is used for start or stop. And then a rectangular shaped shape is used for a process like 1 plus 1, 2 minus 2, or any process there is. And then a decision is usually like, is 2 greater than 1? And then it has arrows going from it, 2 arrows, yes or no. That's what you're going to label them. And then an input or output box. It's not a box, it's more of a parallelogram. So over here, you would usually input or output statements like you'd say input number, input num, and then you'd output result, output product, things like that. Okay, so let's look at an example. Figure 7.2 shows a flowchart for a calculator. So we'll take the calculator example again. So first you have start. It is in an oval shape again. So start. and then the arrow goes down. So you basically need to follow the arrow. Then you see that there's a parallelogram, and as we discussed earlier, parallelogram is used for input. So input num1, you input number, let's say 1, and then you input a symbol, let's say plus, and then input num2, 1 again, and then they're asking you in the diamond symbol, is simple plus? If it is yes, you can see that there are two arrows, right? Yes or no. If it is yes, then the answer is going to be num1 plus num2. If it is no, it's gonna carry out a different set of process. So in our case, yes, it is a plus. So the answer is equal to num1 plus num2. And once that is carried out, it goes straight down to output answer. And you output the answer, which is 1 plus 1 is 2. So 2 is your result, and then it's directly gonna stop. Now let's say we take a different approach. Let's say our number was 2 times 3, okay? These were our inputs. Input num1 was 2, input symbol was a multiplication sign, and input num2 was 3. And then it asks you, is symbol plus? No, it is not, so it goes down. And then they ask you again, is symbol minus? No, so it goes down again. And then is symbol divide? No, and you go down again. Is symbol multiplication? Is symbol star? Yes. So we go there and they give us our answer as num1 times num2, which is 2 times 3 is 6. So our variable answer is gonna store the number 6. And then they're gonna ask us to output the answer, which is gonna be 6. And then the algorithm is just gonna stop. I hope this is clear. Next is pseudocode. So a pseudocode is basically drafting a programming language. It is a universal coding language that doesn't actually work. It's like, designing, basically. You design using codes instead of diagrams, and you write it in statements. And yeah, not much to add to pseudocode. But there are a lot of pseudocode algorithms that you should have a good idea of. We will discuss later on. And then coding. In coding, you do the actual coding using an actual programming language like Python. This is not supposed to be here. Java and C++ are some common programming language that people use daily. So yeah. And then the last process of the program development lifecycle is testing. Now there are two main questions when it comes to testing. Why do we do testing, and what are the different types of test data? So testing is when you have finished your program, you need to carry out testing to make sure it fully works, it does not crash, it meets all requirements. If these three requirements are fulfilled, then you can say that your program is ready to go. So that is why we do testing. And then you will need to identify appropriate test data to use the test program. There are 4 types of test data, and these are the test data types: normal, abnormal, extreme, and boundary. So normal is the data that the program should accept. Like, okay, so let's say we have a condition where a number should be between 1 and 10 included. Okay, so a normal test data for that would be 5 or 2 or 7. So these should be accepted by the program no matter what. And then abnormal test data is that the data in the program should not accept. So let's say 0 or 100 or A. These are abnormal test data, and this should not be accepted by the program. And then we have extreme. It is the data that is at the edge of what is allowed. So 1 and 10 would be the example of this, because they're at the very edge. This is the last number that would be accepted by the program. And then boundary, data that is on the edge of being accepted and being rejected. An example of boundary data would be 0, 1. boundary data always comes in commas, right? So it's two numbers always, or two letters, or two alphabets, something like that. So it's either 0, 1 or 10, 11, because these both numbers are both accepted and rejected at the same time. So I hope that is clear. And yeah, this is program development life cycle.